Welcome to the day 3 video, which covers vertical motion. Today we will be learning the vertical motion equation, how to set it up, and then we're going to be solving for various quantities. This section really contains everything that we've done in Chapter 5, both Part 1 and Part 2. We're going to be looking at solving. So if you remember from the beginning of the chapter, the first half, we did the quadratic formula and factoring and whatnot. And then we've been doing graphing. So this section is going to put everything together. We are going to start out with what is the vertical motion equation. One thing I want to point out is you do need a calculator for today's video. You're going to have a very hard time if you don't have one. So if you need to, please pause the video, find your calculator. So the main vertical motion equation is going to be h of t equals negative 16t squared plus v naught of t plus h naught. Okay, this might look familiar. You have done vertical motion in physics, so this might be similar to an equation that you've done in physics. It might look a little bit different though. Here's what all those variables stand for. H of t is going to be the height of the object after t seconds. V naught is the initial velocity. And h naught is the initial height. Okay, so one thing to know is that v naught and h naught you will always be replacing. So in the equation, you're always going to have numbers you're plugging in there. But h and t are just going to stay h and t. You're always going to have those two variables like you do in any equation. Now, why does this equation make sense? Or what does it tell us if we were to graph it? Well, if we look at that first term, that negative 16t squared, it's going to be a parabola opening downwards. So it's going to look something like this. Now, this should make sense if you're throwing an object. So vertical motion, we're talking about an object, like throwing a ball or a rocket or something like that. Throwing that object, it's going to go up, it's going to hit some point, and then it's going to come back down. So this should make sense. We're going to start by doing an example together, and then at the end of the video, you will do an example. So looking at the example on this page, an object is fired straight up from the top of a 150-foot tower at a velocity of 75 feet per second. Write the vertical motion model to reflect the information above. Okay, so we have to look at the information that we're given. That 150-foot tower, that's our h sub naught. So that's the initial height of the object. That 75 feet per second, that's our initial velocity. So again, looking at that little sketch that we drew, our object starts 150 feet off the ground and it's shot upward. Eventually, because of gravity, it's going to start coming back down again. So if we write our vertical motion equation, we're going to have h of t equals negative 16t squared. It's always negative 16. That's not going to change. Plus v sub naught, so the initial velocity, 75t, plus the initial height, 150. Now, if you want to, instead of h of t, you can just write h. So that's another option for you. Either one of these would be appropriate. So then in part B, use the model to predict the height of the object after 3 seconds. 3 seconds, that's our t. So we want to know what is the height after 3 seconds. So we're going to plug in a 3 for t. So we get negative 16 times 3 squared plus 75 times 3, add 150. Okay, this is why I told you that you should get a calculator. If you plug all that into your calculator, you're going to get a height of 231 feet. So after 3 seconds, whatever this object is going to be at 231 feet. Okay, so moving on, if we look at part C, at what time or times will the object be 235 feet off of the ground? Why are there 2 positive answers? Okay, so at what times, that's telling us that we're looking for t. 235 feet off the ground is the h. So setting up that model, we get 235, that's the height currently, is negative 16t squared, add 75t, add 150. Okay, now this is something that we need to solve, and we do know how to solve this. Thinking back to the first half of the chapter, we need to set everything equal to 0. So I'm going to subtract 235. And I get 0 equals negative 16t squared plus 75t subtract 85. Okay, in terms of our different solving methods, we have factoring, the square root method, quadratic formula, and completing the square. Now, square root method is not going to work here. You could try to factor this. I would suggest that you don't because the numbers are so big. Completing the square won't be very efficient here either. I think our best option is to use the quadratic formula. As a reminder, negative 16 is A, 75 is B, and negative 85 is C. So if we set up the quadratic formula, instead of x in this case, it's going to be t. We get the opposite of b plus or minus the square root of b squared minus 4. Remember that a is negative 16 times c, all over 2 times a. Okay, now you have a calculator, so use that calculator. This ends up being negative 75 plus or minus the square root of 185 all over negative 32. Now, that doesn't make a whole lot of difference to us. That doesn't make sense. I mean, what exactly is that number? So what you should do is get a decimal. Real life, we're going to care about the decimal. In this case, we get 1.919 and then 2.769 seconds. Okay, so one of the questions was, why are there 2 answers? So does it make sense that we should have 2 answers? Well, let's think about that picture that I drew at the top again. So we have this object, it shoots straight up in the air, and then it comes back down at some point because of gravity. Now that object is going to reach 235 feet twice. So let's say maybe this is where that 235 feet is. The object reaches 235 feet when it's on its way up, and then again when it's on its way down. So that should make sense. The object is going to go up, hit a certain height, and then come back down. When that happens, that's why we get those 2 answers. So then the next logical question might be, well, what is the maximum height that this object hits? So that's part D. What is the maximum height that the object reaches? And then how long does it take the object to reach that height? Well, again, think about our picture. Object goes up, comes back down. This is the maximum. Well, what is the maximum? It's the vertex. So we need to find the vertex. Let's remember our vertical motion equation. So it's that negative 16t squared, add 75t, add 150. Make sure you go back to the original model. We're looking for the vertex. As a reminder, x is negative b over 2a. X in this case, I really mean t. So again, here's our a, b, and our c. So t is going to be negative b over 2 times a, which ends up being 2.34375. Now, remember that that's the time. So how long does it take for the object to reach the maximum? 2.34375 seconds. Now, we also want to know what the maximum height actually is, so we're going to have to plug that in. So what you're going to do is you're going to plug that value into your vertical motion model that we wrote at the beginning. If you trust me, it ends up being 237.89 feet. So that is the maximum height that the object reaches after 2.34375 seconds. Okay, and then lastly, the last part of the problem that we're going to do together is part E. How long does it take for the object to fall back to the ground? Okay, so if the object has fallen back to the ground, the height that it's at is 0. So what we're going to do is we're going to plug in a 0 for the height. Again, we're going to have to solve this. Same options that we had before. Quadratic formula, factoring, square root method, and completing the square. Again, I would suggest that we use the quadratic formula because these numbers are big and the quadratic formula is always going to work. So let's set that up. We get t equals the opposite of b plus or minus the square root of b squared subtract 4ac all over 2 times a. This ends up being negative 75 plus or minus the square root of 15,225 all over negative 32. Again, that doesn't mean a whole heck of a lot to us. We need to get our 2 decimals from here. So we end up getting negative 1.512 and then 6.2 seconds. Now, the negative one we obviously don't care about. This is the answer that we care about. So it's going to take the object about 6.2 seconds to fall back to the ground. Okay, so to recap what we've done, we've looked at the vertical motion model, the equation, and then we've used it to find various values. Height at a certain amount of time, how much time it takes the object to get to a certain height. And this puts together everything we've done. We've had to do some solving, we've had to look at parts of the graph, the vertex specifically. So what I want you to do is I want you to flip the page, and there's going to be one that I want you to. I'm going to start this one out with you, and then I'm going to let you finish it. So during World War I, mortars were fired from 3 feet below ground. The mortars had an initial velocity of 150 feet per second. Okay, so that 3 feet below ground, that's our initial height. 150 feet per second, that is our initial velocity. So if we write the vertical motion model, the height after a certain amount of time is negative 16t squared plus initial velocity times t. And then we're going to add the initial height. Well, it's 3 feet below ground, which means that the initial height is negative 3. Now, hopefully we recognize that if you have the wrong value for the initial velocity or the initial height, you're going to get the wrong answer. So it's very important that you write the model correctly. Okay, so what I want you to do is I want you now to pause, take 5-6 minutes, and complete the problem. Once you're done, you're going to come back and I'll give you answers, but I'm not going to show you work. Good luck. Okay, let's see how we did. For part B, 7 seconds, that should have been your time. If you plug in t is 7, you get a height of 263 feet. And then if we go on, for part C, that 300 feet off the ground, that was the h. So you should have plugged that in for h. Move everything to one side. And then you would have needed to use the quadratic formula to solve this. When you solve it, you should have gotten about 2.95 and 6.43 seconds. If that's not what you got, look back at your work and try to figure out what happened. For part D, maximum height, you should have found the vertex. So if you do your negative b over 2a, again, it's not really x, it's time in this case, you should have gotten 4.6875 seconds. So that's when the mortar actually reaches its maximum height. Once you plug that in to the height, you get 348.5625 feet. And then for the last one, when our mortar falls back to the ground, that's when our initial height is 0. So go back to your original vertical motion equation, and for the height, plug in 0. Again, we've talked about this. You're going to have to use the quadratic formula. You can try to factor, probably not going to factor. I would suggest you use the quadratic formula. 2 answers that you should have gotten were 0.020 and 9.35 seconds. Now, why did we get 2 answers? Well, if we're shooting the mortar from below ground, it's going to hit ground level twice. It'll hit ground level on the way up, ground level on the way down. So this one we don't really care about. This is the answer we care about when the object falls back to the ground the second time. So hopefully these went well for you. If you made any mistakes, please make sure you go back and fix them. When you come to class tomorrow, we will be making sure that you have all of the work shown. If you just have the answers like I listed in the video, you will not get credit. Now, there is one last piece that you need to know. It is possible to do to find some of these answers quicker using a calculator. If you are interested in learning that, there's an optional video on Schoology that you can watch that will teach you how to use your calculator better. If you don't care to know the calculator, the way I've shown you in the video will always work. So if you're interested in learning how to use your calculator better, watch the optional video on Schoology. If not, I'll see you tomorrow.